Good morning, everybody. We're starting into chapter 8. First of all, welcome back. Everybody, we're so glad to get back to business again, and hopefully, we're going to finish this year strong. Again, we're starting into chapter 8, talking about right triangles and specifically using, at least now, the Pythagorean theorem. So, I want to talk a little bit about right triangles themselves, go over a few terms, look at the theorem itself, and try to work through just a couple of problems for you. Again, this packet is kind of self-explanatory. You can kind of read that on your own. I know you're learning to be adults, so I don't need to read it to you. But I did want to go through a few problems and just make sure that everybody knows what we're doing. So, first of all, notice that we have a triangle here that has a right angle in it. So, anytime you have a triangle that has a right angle in it, that is considered a right triangle, but it also creates some interesting relationships in that triangle. So, a couple of things we need to look at are some terms. So, you notice we have a leg here that we'll call a leg that comes off of this angle. It's directly connected to this angle. We also have another one right here, okay? So you notice they have those labeled A and B. So we're going to call those both. Those are legs, and those are kind of interchangeable. And what I mean by that is I could have named this one B just as easily as they named it A. I could have also named this A. I could have interchanged those labels around. It doesn't really change the problem or change what the situation is at all. So when you're labeling these, it doesn't really matter how you label them. Obviously, we do need to pay attention to whether we're being asked to find a leg or being asked to find a hypotenuse. And so you say, well, what in the world is a hypotenuse? Well, a hypotenuse is a very specific side. So these doesn't matter. They could be interchanged, but this one is really, really important, okay? So the hypotenuse, there's two ways to know that you're dealing with that particular side. One is that the hypotenuse is always the longest side. So even though this one may look very similar to this one, it is in fact the longest side. The other way that I think probably is the best way to look at this is the fact that it is always across from the right angle. So you notice the hypotenuse is always across from the right angle, and that's probably one of the best ways to try to figure that out. So you're thinking to yourself, well, why in the world does that help? How is that helpful? Well, there's a very smart mathematician named Pythagoras who discovered that there, again, are relationships within this type of triangle. And so he came up with a theorem, which is why it's called the Pythagorean theorem. It's named after him. And he came up with this theorem, and here you can see this listed as c squared equals a squared plus b squared. The way we've typically seen that, and it's equal to the same thing, is a squared plus b squared equals c squared. Okay, and you say, well, what in the world does that mean? Well, think about what a and b are. A and b are your legs. And so what this theorem basically says is this, if I square one of the legs of a right triangle and I add to it the square of the other leg, then it should equal the hypotenuse, which is c squared. So I have leg squared plus leg squared, and that would equal the hypotenuse squared, okay? Now that is a very useful theorem because it helps us to try to take two sides of a right triangle, and then we can use that to try to help us to find that other side, no matter what that side may be. So on this first page, on page 64 here, it goes through an example. We won't go through that example. Actually, I want you to turn to page 65, and we're going to go ahead and work number one here and make that a live problem. Okay, so for number one here, notice it says that we're looking for the hypotenuse. Use the Pythagorean theorem to find the length of each hypotenuse in the triangles below. So on all these particular examples on this page, we're going to be looking for C, which is the hypotenuse. So one of the first things I would encourage you to do is to go ahead and write down your formula every single time. That'll help you to remember it. So a squared plus b squared equals c squared is what we're doing, okay? Now, remember we said that it doesn't matter about these two legs because we're going to end up adding them anyway and squaring them. So that is a commutative property, and it doesn't really matter which one's A or which one's B. Actually, I had a student at one point in time that told me that anytime it's an upright side, it's always A. Well, if that helps you to remember it, that's fine, but it doesn't really matter, okay? So I'm going to go ahead and call this one A, and I'm going to call this one B, okay? So now literally all I have to do is substitute my values back into the problem. So I'm saying that A is this 3-inch side, okay? So for A, I'm going to put in a 3. So I'd put 3 squared plus, and I'm going to add to that this side squared, this leg squared, which is 4 squared, and it equals C squared. Now this is actually getting us into exponents, okay? And it's actually kind of helping springboard us into square roots as well, which you'll see here in just a few minutes. So now let's work through the actual math. We have 3 squared. Now think about what 3 squared really is. 3 squared, when I have this exponent up here, it's basically just telling me that I need to repeat this base. This is my base. I need to repeat this base twice and do multiplication in between. So 3 squared is the same thing as 3 times 3. Well, 3 times 3 equals 9. So 3 squared would be 9. Same thing for here. I'm going to add to that 4 squared. Well, 4 squared is the same thing as 4 times 4. 4 times 4 is 16. And then that equals C squared. Now, I can't forget to keep bringing that squared down because I've not really did anything with that yet, okay? So now let's finish up what math we could do. We've got 9 plus 16. 9 plus 16 equals 25. And so 25 equals C squared. Now remember the law of equations. I need to isolate this C and get this C by itself. So in order to do that, I have to get rid of this squared term. Well, how do I get rid of something that's squared? Well, I have to do the inverse of squaring it. So let's think about something for just a second. If I take 2 times 2, which is the same thing as 2 squared, right? 2 squared is the same thing as 2 times 2. That gives me 4. Now, how could I take that 4 and somehow get it back to a 2? Well, let's think about the square root. The square root of 4 means that I'm looking for a number when multiplied times itself will equal 4. Well, the square root of 4 is 2 because I could take 2 times 2 and it would equal 4. So that brings me right back to the original number that I started with. So what I want you to understand is that the inverse of squaring something is to take the square root of it, okay? So in order to get rid of this squared over this C, I could take the square root of C squared. But if I do it to one side, I also have to do it to the other, right? With equations, whatever I do to one side of the equation, I have to do the other side. So that means I also have to take the square root of 25 right here. You may say, well, I don't know what the square root of 25 is. Well, let me show you something real quick here with your phone. And so most of you have a phone or a device that you could use. So here's my phone, and we could click the calculator button. And all of a sudden that brings up a calculator, and you're thinking to yourself, so what? I still don't see anything that looks like square root. Well, if you turn your phone around long ways, and you might have to tilt it up just a little bit, you can see that all of a sudden now we have all kinds of options, okay? And if you notice right here, you have a square root button, okay? So if you have a cell phone or device, iPad, anything like that works, you probably can get this type of calculator. So here I'm just going to go 25. And I'm going to go ahead and click that button right there. And you notice it gives me an answer. The square root of 25 is, in fact, 5. And that makes sense because 5 times 5 equals 25. So this becomes 5. The square root of 25 is actually 5. And what happens over here? The whole reason I did this was because I wanted to get rid of this square that was over my C. So now I'm left with just simply C. So C equals 5. So you can see how we use the Pythagorean theorem in order to figure out what this particular side was. Now notice this time we were looking for the hypotenuse. If you go to page 66, it begins to give you an explanation of doing this in order to be able to find the length of a side, okay? Again, this kind of goes through the example, so if you need to come back and refer back to this, you can. But I'm actually going to work an example with you. So we're going to look at number 1 on page 67. And again, let's look at what we're given here. We're given a value here, and then it's asking for side A or leg A, okay? So first things first, let's write down our formula. A squared plus B squared equals C squared. Now let's try to identify what else we've got. Is this B or is this C? We have the A already. It's right here. but which one is this? Well, in order to figure out the hypotenuse, remember, here's my right angle. I'm always going to look at the side that's opposite my right angle, and that's going to be my hypotenuse. And what letter does the hypotenuse have? It has to have C. It is very important that it be C. Okay, so that means that this one is actually B. So now I can begin to substitute in my values into my formula. Now I have A squared plus B squared. Well, it tells me that B, I've identified B as being 12. So 12 squared equals C squared. This time I know what C is. I'm not looking for C. I've already been given it. So C is 15. I'm going to go ahead and put that in, substitute that in for that value. Does everybody see what we've did so far? We're looking for A. We've identified this as B and this is C. So we've just substituted those values into the formula. So notice what happens. We have A squared. I still don't really know what that is, and I can't forget that it's still being squared, plus 12 squared. Well, 12 squared is the same thing as 12 times 12, which is 144. And 15 squared is 15 times 15. Now, again, you might have to get your calculator and try to figure out what that is. It's actually 225. Okay. So now we have to figure out, okay, how do I get A by itself? Well, again, with equations, I know that I need to get this value out of the way. I need to get it to the other side. Right now I'm adding 144, which means I need to subtract 144 from both sides. Notice what happens. I'm left with A squared. This goes away because 144 minus 144 goes away. And now I have 225 minus 144. 225 minus 144 actually equals 81. So now I've got to think, how do I get this A by itself? Well, it goes right back to what we did with the previous problem. We've got to undo this squared. So in order to undo a square, you have to take the square root. And if I do it to one side, I have to do it to the other side. So I end up with A equals the square root of 81. The square root of 81, what times itself will make 81? Well, you can use your calculator. You could also use a little mental math. So let's think about 8 times 8. 8 times 8 gives me 64, so that's too small. 10 times 10 gives me 100. That's a little bit too big. So maybe it's the number in between. Let's try 9. 9 times 9 does, in fact, equal 81. So the square root of 81 is 9. Again, you can use your calculator to do that as well. But we have now figured out that A equals 9, and that is our answer. I want to show you one more little note that you need to pay attention to, and it's right here. Okay, this note right here says that the sides of a right triangle have lengths of 3, 4, and 5. So anytime you see two legs that are 3 and 4, you know that that other side has to also be 5. And it could also be in multiples of these. So you see 6, 8, and 10. So again, that will come into play a whole lot. That is actually called a Pythagorean triple. So that is something that you really need to take note of right there. Okay. What you're going to do is you're going to finish out the rest of these problems. We've got 4 more pages, but relax. It's not really that many problems. These are more application problems that you're going to have to think about just a little bit. Okay. And think about what you're looking for. So you got page 68 and 69 right here. And then you've also got page 162. I know it jumps quite a bit there. 162 and 163. Now, what I want you to notice about page 162 are your instructions. It says find the approximate square root. And so you're going to be estimating. You'll notice in number 1, they actually use this little approximation symbol like that, which means that they have rounded this to 100. So you're going to be doing a little bit of rounding. As long as your answer is close and not way, way off, then we'll know that you knew how to do it properly, okay? So have a good time with this. This is a good intro packet into this new chapter that we're going into. Again, it's going to get a little bit more difficult as we go. You expected that, or you should expect that. But this is just to try to help us kind of get into it here in the beginning. So if you need any help, as always, just ask me or Miss Willer. We'd be glad to help you with it.